Believe it or not, this is going to be take two of this. All right, well, let's dive right into it. This is going to be the suspension principles. What is a suspension? Glad you asked me. A suspension is basically going to keep the tires grounded at all times and assist with a comfy ride, or help you on your landing if you're doing some Dukes of Hazzard stuff in your cars. All right, let's get down there. So then, what are the components of a suspension? Well, there's frames, we got platforms, we got the sprung weight. There's many components of it, but let's dig into frames because it's just right here. So, as you can see, there's different types of frames. There's ladder frames, perimeter frames, step type frames. Let's all go through it. The first one I guess I'll go over is going to be the unibody frame. The unibody frame is going to be looking like this, where kind of like you have a whole clusterfuck of plastic material and like the carbon fiber and the steel, and overall the whole skeleton. It's like a think of the skull. The skull is actually a good example of a unibody frame because it's a lot more complex. It contains the components of the doors, of the everything else. Whereas you have a ladder frame, and a ladder frame kind of, it's, my picture's a little weird, but it's going to contain two cross beams. Imagine this section being the front lights and this section being the tail lights. There you go. Can you see it? Can you see it? There you go. And then you have these little cross beams right here. 1, 2, 3, 4. Kind of like supporting the underside of the whole chassis and the body of the car. There's a little image right here. There you go, something like that. That's supposed to be representing the cross frames I was mentioning. And then the next one's gonna be, where you at? Oh, there you go, the parameter frame. This one's gonna be more of surrounding the car, the outside of the car. So as you can imagine, this type of frame would be like the ones held in Crown Vics, and I already told a story about that later, and I'm not going to introduce it again. This is going to be a stub type frame. I know it looks like a shoe, but just pretend that shoe thing right there, like this thing right here, is going to be the car, like a car body. And then these squiggly lines right here, these front two, are going to be like the steel frame, like steel rods. And then this back part is going to be the other part of the steel rods. As you can see, there's a separation in between them, and that's supposed to be a picture like that. So imagine that blue part being the unibody, and then those black steel frames or whatever, a sub-type style of frame. All right. So just to illustrate it one more time to make it clear, this is going to be an unibody where basically it's like a skeleton. You can't take any part. It's not drivable. Like it surrounds the drive chain, the engine, the suspension, all those components are integrated into the unibody. Whereas you can make this work as long as you have the wheels, the drivetrain, the suspension, and the engine. Just put that stuff on there and you could separate it. Whereas a unibody is basically inseparable. That's a good way to think of it. And so yeah, there you have it, the different types of frames. Oh, we forgot a space frame construction. You could think of those as Jeeps. Think of Jeeps being a space frame type of construction, where you could take off doors, and the whole like frame of it is like kind of like, it's almost like, think of a skeleton, like a Jeep, like those Wranglers. That's a good example. All right, let's move on to platforms. I don't know why I've written platforms here, but it's basically the size and shape of the vehicle. You could think of them as kind of like being the overall plan. Like if you think of a person, the person's platform kind of looks like theirs, and then when they have children, they kind of look like their platform. And like if you put their head on top of another person, their children's head, they kind of have the same fit, but they don't. That's kind of the thing. Like Hondas have the same platform as Hondas, Mazdas have the same platform as Mazdas. I hope that made that concept clear. Now, another thing that I want to dive into is going to be the bulkhead. The bulkhead is basically going to be a sheet of metal or a component of the car that separates the engine from the passengers. So it's basically the dividing line that cuts in between those two parts. So then what next do we have? Here we have the track and wheelbase. Now the track and wheelbase is a base that describes the distance between two wheels. So then the track base is going to be the difference between the side wheels. So if you imagine you're looking at the car, these two black dots are going to be lights, and this is going to be like the windshield. This is going to be a tire, and this is going to be a tire. The track base is going to be the distance between these two tires. Now if you imagine this being as if you're looking at it and you have, like, you know, a person's head right there, and then it's getting blurry. Oh shit. All right, there. And then you have like the light, they're going this way. The wheelbase is going to be the distance between the front wheels and the rear wheels. Now, interesting dynamics is going to be if you increase the distance of the track base, that means your ability to corner turns is going to be a lot more stable. And if you think about those Crown Vics, they had a huge track base compared to, like, you know, your average car. And if you have an increased wheelbase, that means it's going to make it a lot more smooth. It's going to make for a smoother ride. And as you can imagine, you can think of the Cadillacs, the Lincolns, the limousines. They all kind of have like that smoothness to them. So let's move on. Next thing is going to be the unsprung weight. Unsprung weight is going to be basically the weight that a spring is not. How do I say it? So this is a sprung weight. The sprung weight is going to be the load that the spring is like holding up, the force that's acting on the spring going down. The unsprung weight is kind of like the base of it, like, and like it's going to be basically bigger, the bigger load, or what the spring is going to be kind of like, you know, catching and stuff like that. In this instance, the unsprung weight is going to be, where is it at? The freak did I put that thing at? Oh god, see, I can't remember. I have my notes. So this unsprung weight is going to be the portion of the weight not held up by the spring. So, like, you know, in this instance, it's going to be the wheels. And then the sprung weight is going to be the portion of the car or the part that is held up by the spring, which is basically going to be the whole, you know, body, the engine. It's going to be the one that's kind of like moving and stuff like that. So then let's talk about suspensions. There's going to be an independent suspension and these type use springs. Now, quick note on independent suspensions. Independent suspensions are ones that use springs. Hold on, let me get this right. There you go, springs like these. And I guess we'd call them dependent suspensions, are going to be like this. Now, the problem with dependent or non-independent springs is that when there's a bump on one side of the wheel or something like that, it's going to affect the other side of the wheel, as you can imagine. This is supposed to represent like a wagon think, or something like that. So as you can imagine, the wagon being on top of that solid axis right there. Yeah. However, if you have a spring like that, that means the wheels are gonna, like, if you have a bump on one side of the wheel, it's not gonna affect hugely, I guess you should say, the other side of the wheel. So, yeah, where am I at? Aha! So then, using springs on all wheels absorbs the vehicle's movement without passing it to the frame, which is pretty good, you know, if you have like, if you're going off-road or something like that. Passes vehicle weight to, oh, I remember this. So basically, the functions of a spring are kind of like this, kind of like two things you think of that happen when a when a spring is used in a car. First thing that happens is it absorbs the force, or just absorbs energy, I guess, as a car goes up on top of that bump. So, and then the second thing is it passes that and deflects it to the weight to the respective component. So basically, it softens a blow of the bump, and then after that, it causes the spring kind of like recoils back and then goes straight down to the ground. So very critical is the material of this spring. Now normally the book says it's going to be tempered steel alloy, which is going to be resistant ability to return. Oh, there you go. So basically it's going to be tempered steel alloy. I have a buddy that actually knows a lot about steels and stuff like that, but they use that because it has a good resistance. And in this instance of talking about resistance is to express the ability to return to the original shape. So basically the spring's resistance is its ability to return to the original shape. Alrighty, so then the book also goes into Hooke's law. What is Hooke's law? Basically the deflection of the spring, or as you can think of the spring being wounded up like that, just like squeeze it up like that, is proportional to the applied force. So if you depress or apply force to displace a spring, it will be exerting a certain force, and then that's exactly proportional to the energy you put into displace it. So for example, if you displace a spring by 1 inch, it will be exerting 400 pounds back, and then if you displace like another inch, it's going to be 400 pounds back, and then after that, you know, it keeps on going. So each inch is basically going to, you need 400 pounds to make this spring move 1 inch. And then this is going to be called the spring rate, and this is going to be in pounds per square inch, 400 pounds per square inch in this example. So then let's go into the coil springs. Handling characteristics. So this is kind of like the meat and the bone of springs. Now, what kind of determines how stiff a spring is, or the spring rate, if you want to go into that, if you want to think about that. How am I going to go into this? And we'll just talk about the characteristics of a spring. There's 4. You got the coil diameter, which is going to be the diameter of the coil. You're going to get the height of the coil, the number of the coils, and how thick the coil is. So the few coils means it's going to be, are you sure about that? Few coils means it's going to be a little bit more stiffer. As you increase the diameter of the steel, so like this part, it's going to mean it's going to get more stiffer, so like it's going to be harder to press, and it's going to be coming back at you a little bit more. And then the height, if you decrease the height, it's also going to decrease the stiffness of it. Now I'm going to recheck this real quick because I don't know if that's necessarily right. There you go, that's what I'm talking about right there. Fuck yeah. Give me a moment. There you go, it says it right there. See if you guys can see. I'll read it to you. The larger the diameter of the steel, the stiffer the spring. So basically, if you have like a huge diameter or a really thick spring, then it's going to be more stiffer. The shorter the height of the spring, the stiffer the spring. So like if you cut this in half right here, this example, you cut this bitch in half, and that means it's going to be a little more stiffer to press. Whereas this one, you could just like whoop, and then the fewer the coils, the stiffer the spring. So as you can imagine, if you only have like 1, 2, 3 like that, really thick, it's gonna be like, whereas if you have a huge amount of them, it's gonna be like, there you go. So, and here's an equation if you guys want to use it, if you guys are ever making springs. It's going to be K equals G, which is going to be the constant for the steel, the diameter of the wire, times that bitch by 4, divide that by 8, multiply that denominator by the number of coils, and the diameter of the coils. So, let's continue. So then the spring weight is basically going to be how much weight is needed to compress it by an amount of X. So how much weight is needed to compress that spring down. And usually it's going to be a constant. Oh, I get it now. So the rate, the spring rate, like it's like the, what is it? How much rate? Oh, now that's gonna, the spring weight, meaning how, spring rate is basically gonna be how much you could compress this spring bitch down all the way. Now, Hooke's law basically said it could be proportional. It's proportional, meaning you put one, there's actually a picture right here. There you go. So you put one weight down, which is gonna be 100 pounds, you get 1 inch. But add another 100 pounds on top of that, like another 100-pound brick, you get 1 inch. And then same thing times 3, you get a total of 3 inches. So you could basically call this a 100 pounds. The spring rate of this thing would be 100 pounds per inch. However, there's other types. There's a variable spring as well. So a variable spring is basically going to be, as you compress it, the more you compress it, you're going to need more force to compress it. And oftentimes these are implemented in cars to give you a more soft and comfy ride. Here's that spring rate equation I was showing you. The spring frequency is basically going to be the speed at which a spring hand is shaking. A spring bounces off after compressing it, and this is going to be expressed in hertz. And usually the spring rate is going to be have a direct relationship to the spring frequency. So increasing the spring rate means increasing the way it's going to be bouncing back off you. That's all I got. I hope you guys enjoyed it.